SQL injection is one of those vulnerabilities that feels like it should have been extinct years ago. Yet here we are in 2026, still seeing databases left wide open like unlocked diaries with "Hack Me" written in neon marker. If you're a developer, cybersecurity professional, or just someone curious about how systems break, understanding SQL injection isn't just useful, it's essential. Today we are going on a deep dive. We will explore why this 27-year-old vulnerability persists, how attackers exploit it, and most importantly, how you can protect against it. Imagine running an exclusive VIP club. Your bouncer has one simple rule: whisper the secret password to enter. But then a clever guest shows up and says something like, "The password is anything, or just let me in anyway." The confused bouncer, following instructions literally, opens the door. This is SQL injection in essence. When you enter credentials on a website, they're usually checked against a database with a query like select from users where username equals input username and password equals input password. But what if instead of admin, we input or 1 equals 1? The query becomes select from users where username equals or 1 equals 1 and password equals anything. Since 1 equals 1 is always true, the database returns the first user, often an administrator. That's the fundamental flaw, trusting user input without question. Types of SQL injection. 1. Union-based SQL injection. Uses union operator to combine results from different tables. The union operator lets attackers append their own queries, stitching together unauthorized data like a digital Frankenstein. Why it works: poor input validation allows union to append unauthorized queries. Example: normal URL of a website, http example.com products category gifts. Normal query in backend, select name, description from products where category gifts. Hacker change the URL and add a SQL injection payload. The URL become http example.com products.php, category gifts union select username, password from users. Resulting query combines product data with sensitive user credentials displayed on the page. Only using one payload the hacker get all the database data if the website vulnerable by SQL injection. 2. Error-based SQL injection. Forces database errors to leak sensitive information in error messages. Hacker add a single quote in website URL for testing error-based SQL injection. Example: normal URL of a website, http site.com product ID 1. Hacker add a single quote. The URL become http site.com product ID 1 single quote. That single quote breaks the query, and insecure configurations spill database secrets right in the error messages. After confirming the vulnerability, hacker test more payloads and get data from database. 3. Boolean-based blind SQL injection. In this attack, the hacker does not see any data on the screen. They only see true or false behavior. The website looks normal if the condition is true. The website changes if the condition is false. The attacker asks questions to the database one by one, like a game. Example: check true condition, hacker add payload and 1 is equal to 1. The URL become site.com profile PHP ID 1 and 1 is equal to 1. Page looks normal. Check false condition, hacker add payload and 1 is equal to 2. Site.com profile PHP ID 1 and 1 is equal to 2. Page looks different. By checking these small changes, the attacker slowly guesses and steals data. 4. Time-based blind SQL injection. The sneakiest variant. No errors, no data leaks. Just waiting. If the page loads after 5 seconds, they know their condition was true. It's like cracking a safe by listening for clicks. Example: hacker add payload in website URL. Site.com item.php ID equals 1 and sleep, 5. If page loads 5+ seconds, the website is vulnerable. Time-based is slow but stealthy. Now let's talk about how to test for SQL injection ethically and methodically. Step 1. Reconnaissance and information gathering. First, we collect information about the website. No hacking yet, only observing. Tools. Wapalizer what web and built with. These tools show what technology the website is using. And identify, database type, backend language and framework etc. Step 2, Attack Surface Identification. Attack surface means all the places where users send data to the website. After reconnaissance, the next step is identifying the attack surface, meaning the places where user input reaches the server. URL parameters, numbers or text and links like ID equals 1. Form fields, boxes where users type, login, search, contact. HTTP headers, hidden data sent by the browser, cookies, user info. File uploads, when users upload images or files. API endpoints, background URLs used by apps and websites. These are the input points to test for SQL. Step 3, Detection and Fingerprinting. Now we check if SQL injection exists, without damaging anything. 1. Basic characters. Check if the website shows errors. 2. Logical tests, and 1 is equal to 1 versus and 1 is equal to 2. See if page behavior changes, true or false. 3. Time tests, or sleep. 5. If the page loads late, it may be vulnerable. 4. Union probe, order by 1. Used only to understand how the query is built. Goal, only detect the vulnerability, not exploit. Database fingerprinting. Different databases respond differently. This helps identify the database type. MySQL, MySQL, PostgreSQL, Oracle. This step is only for understanding the environment, not stealing data. Step 3, Exploitation. If a vulnerability exists, we test it in a controlled and legal way. Check what data is accessible. Confirm impact without dumping real user data. Stop testing once proof is found. In real work, proof is enough, no need to go further. Step 4, Post-exploitation. This is where ethical hackers differ from criminals. Write everything you tested. Create a clear proof of concept. Explain how serious the issue is. Prepare a professional security report. The goal is fixing the problem, not abusing it. Golden rule: always remember. No errors does not mean no vulnerability. Some attacks are silent and need patience. Automation tools, ethical use. Tools help speed up testing, but only if you understand the basics. 1. SQLmap, automates SQL injection testing. 2. OWASP app, website security testing tool. 3. BBQSQL, helps learn blind SQL injection. 4. DSSS, small tool for quick checks. Use tools only on systems you own or have permission to test. Tools don't make you a hacker. Knowledge plus responsibility does. Learn manually first, automate later. Let's analyze actual SQL injection reports to understand what makes a winning submission. Report 1, API-based SQL injection. Target, Hyperpure e-commerce supply platform. Attack vector, sales lead API endpoint used during user registration. Method, Boolean-Based SQL injection using and/or conditions to test database behavior. What the attacker did. 1. Sent normal API requests. 2. Added logical conditions true-false. 3. Observe response changes. 4. Confirm database interaction without errors. Impact. Attacker could add fake data into the database. Confirm database existence and structure. Manipulate backend API logic. Bounty, $2,000. SQL injection is not limited to URLs. APIs are also vulnerable if input is not validated. This was reported responsibly through a bug bounty program. Never test APIs or websites without permission. Report 2, blind SQL injection via API. Target, InDrive, id.indrive.com. The vulnerability is blind SQL injection. Attack vector. Public API endpoint used by a promotional feature. The method that used. Boolean-based blind SQL injection. The attacker changed input values and observed different responses, data returned versus empty response. What the attacker observed. When the condition was true, the API returned data. When the condition was false, the API returned nothing. This difference confirmed a blind SQL injection flaw. Impact of this vulnerability. Attacker could extract database information step by step. Identify database version. Potentially access sensitive backend data. The hunter rewarded $4,134 bounty for this report. Report 3. SQL injection bypass via login endpoint. Target, Acronis, WordPress-based website. Vulnerability, blind SQL injection authentication bypass. Attack vector. Login page endpoint used for user authentication. Method used. Time-based blind SQL injection. The attacker sent special input and measured server response time to confirm database execution. What the attacker observed. When the database was forced to delay, the response came late. When no delay was added, the response was fast. This time difference confirmed a blind SQL injection issue. Impact. An attacker could bypass login protections. Interact with the database silently. Potentially access or modify sensitive data. Even login pages and CAPTCHA-protected forms can be vulnerable if inputs are not safely handled. This vulnerability was responsibly reported through a bug bounty program. Testing login systems without permission is illegal. Remember, if user input reaches a database without validation, SQL injection is always a possibility. All the real vulnerability reports shown in this video are public bug bounty cases. You can find the original report links in the video description for learning purposes. If you are a developer, this part matters most. Never trust user input. Anything from users can be dangerous. Use parameterized queries. SQL plus user input should never mix directly. Stop using string-based queries. If you are joining strings, you are doing it wrong. Use ORM and secure frameworks. They protect you by default. Limit database permissions. Your app doesn't need full database access. Hide database errors. Errors help attackers, not users. Test your app regularly. Find bugs before hackers do. SQL injection persists not because we do not know how to fix it, but because we are human. We rush, we forget, we assume. But in cybersecurity, assumptions are vulnerabilities waiting to be exploited. Remember. Do not trust. Verify. Always. SQL injection remains a critical vulnerability whether you are securing applications or hunting bugs. Remember these key takeaways. Fundamentals first, understand how SQL queries work. Think like the database. What's the actual query being executed? Test everything, all inputs are potentially dangerous. Document rigorously, your notes are your greatest asset. Stay ethical and legal, permission is everything. Never stop learning, new techniques emerge constantly. If you found this guide valuable, help us grow by smashing that like button, subscribing, and hitting the bell icon. Share your SQLi experiences in the comments below. Thanks for watching. Stay curious, stay ethical, and remember, with great power comes great responsibility. Happy hacking, and I'll see you in the next video.